Hello, my dear students of ICSE Class 10th. So see, this is question number 12 of the competency series which we are doing on our channel. If you have not watched the previous questions of the series, you can check the link given in the description box of this video. So let us start with this question 12, a very important question, a very good question from Force chapter 1 of physics. Calculate the weight of the uniform meter rule in the following figure if the meter rule can be balanced at 60 centimeter mark when a weight of 5 Newton is suspended at 100 centimeter. So the question is only a one sentence question. Everything is told in one single sentence, but a lot of things has been told. So let us break the question into bits and parts and let us understand the question. So what we need to calculate? We need to calculate the weight of this uniform meter rule. We need to find the weight of the uniform meter rule. Now, uniform meter rule is a 100 centimeter rule where the mass of it is uniformly distributed. Okay. Previous question also that I uploaded, question 11, that was also based on the same concept of uniform meter rule. So there I also discussed what a uniform meter rule is. Okay, very easy. So uniform meter rule is a 100 centimeter length rule. The word meter itself tells that the length is 1 meter or 100 centimeter. So you can see the diagram is given that this end is 0 centimeter mark and the other end is 100 centimeter mark, which is already shown in the question. Now we have to find the weight of the meter rule. Very simple. Now what is said that this rule is balanced. This rule is balanced. When I say it is balanced, it means I can apply the principle of moments. Anti-clockwise moment is equal to clockwise moment. Clear? Because the question tells that this rule is balanced, and balanced at which mark? At the 60 centimeter mark. That means the pivot is at 60 centimeter mark. So you can see that is also shown in the question itself, that this triangle, which is the pivot or the knife edge, is at 60 centimeter mark when a weight of 5 Newton is suspended at 100 centimeter mark. So you can see that is also shown. A 5 Newton has been shown on the 100 centimeter mark. So this is a balanced situation. Okay. Now I have just copied down the same figure below. This is the same diagram. I have just copied it down because I am going to solve this question. So the solution I am doing here, and it is the same diagram. Now one force is missing in the question, which we need to show in the figure. What is that force? See here, one thing is very clear, that this rule is balanced because the question is telling us that the rule is balanced. If it is balanced, it means that anti-clockwise moment is equal to clockwise moment. So this 5 Newton force is producing the clockwise moment about this fulcrum. But to counterbalance this clockwise moment, there should be another force which is producing an equal amount of anti-clockwise moment, because only then this rule can be balanced. So which force is producing the anti-clockwise moment? We are not able to see any force producing the anti-clockwise moment in the figure. So we know it. What is that? The weight of the meter rule. And the weight is not shown, but we know where it is acting. A uniform meter rule has its center of gravity exactly at the midpoint. So if it is a total of 100 centimeter meter rule, so exactly in the center where 50 centimeter lies, there should be the weight of the meter rule, which we have to find. We have to calculate it. This W Newton, this W force is, which is the weight of this body, is actually producing the anti-clockwise moment, and of course this 5 Newton is producing the clockwise moment, and both of these moments are equal and the rule is balanced. The picture is very, very clear right now. So now on this side I'm going to solve this. What we have to write? We have to write according to principle of moments, anti-clockwise moment is equal to clockwise moment. Simple. Anti-clockwise moment is due to this W force. So W multiplied with the distance of W from the pivot. What is that distance? This distance, isn't it? Here is 50 centimeter where the W is acting, and the pivot is at 60 centimeter. So 50, say 60. What is the distance? It's 10 centimeter. 60 minus 50. So you just multiply W with 10. This is the anti-clockwise moment, which we have to equate with clockwise moment. Clockwise moment is because of this 5 Newton. And what is this distance? So here you have 100, here you have 60. Always we need to calculate the distance from the pivot to the line of action of force. So pivot is at 60, the force is at 100, so 100 minus 60 is 40. So this distance is 40 centimeter. So we'll multiply 5 Newton with 40 centimeters. So we can cancel this. 10 fours are 40, and we have W is equal to 5 fours are 20 Newton. So we have got the weight of the meter rule. The weight of the meter rule is 20 Newton. I hope you have understood every concept nicely and you have enjoyed while solving this question. So we are doing this competency series. You can take a look of all the questions that we have done so far in the series. The link is given in the description box of this video. Also, I want to tell you that my live structured full year online course is also available, where I am taking Zoom classes, online live classes. If you want to join that fully structured course where I'm going to cover the full syllabus of physics, so you can contact me on the WhatsApp number 94307078881. You can join my live online batch where we are doing the full course of physics in a complete structured manner. Everything will be covered with live classes are there. We follow a strict routine. Then we have worksheets, we have tests, we have revision sessions, so many things. You will enjoy the live batch. If you are interested, you can contact me. So take care. God bless you. We'll see you in the next video.